Right then. All right, good morning, afternoon, evening, wherever you are. I'll welcome you guys to the OM upstream feature meeting. My name is Wolf, and today is January the 27th. And let's take a quick look at the agenda. So just a quick reminder, today is actually January the 27th, even though we have an item for the February the 10th, but that will be the next meeting 2 weeks from now. I think that's from Chris and Nathan. I guess they need a little bit more time to prepare for that particular discussion. So for today, we will have one item from Joe Lanford on the Cooper bag, apparently, for the bundle and bundle instant API. Joe, are you here?
I'm here.
Wonderful. All right, then I will pass this over to Joe to presenting his item. Go ahead, Joe.
All right. It says you need to stop sharing before I can share.
Yes, give me 1 second.
All right, so give me a sec. This is annoyingly asking me to authenticate a bunch of stuff to give Zoom access to my desktop. I'm going to be right back. All right, let me try again. Okay, can you see a terminal coming up?
Yes, I can.
All right, great. So what I want to do is set up a few windows here. So just to give a little overview, so the OLM team has been talking about Ruckpack and a bundle API and a bundle instance API. And the idea is basically a bundle API can be used to define basically which bundles we want to be made available to the cluster. So like something that can make the manifests and the bundles and the metadata about those bundles available in an API-centric way. And then the bundle instance API is something that can actually take those bundles, render them into something that actually gets deployed onto the cluster such that, the bundle is effectively running and applied. So I put together a really quick kind of proof of concept for how that might work with our existing registry v1 bundle type. So without further ado, so I've got a cluster running on my desktop. We'll do make run, which will start up the controller, and then navigate over there here. Okay, so everything's running. We don't have any jars or anything yet, but I've got a couple examples here that we can look at. So this bundle.yaml, I've got two bundles. Notice it's very simple. The name is just a normal Kubernetes name, and the interesting thing is the image. So this is just a normal bundle image that we all have been familiar with. And then if you paid attention to the Ruckpack API, there's this notion of provisioner classes, which is effectively a way that you can have a different provisioner know how to handle a bundle in a bundle instance. So in this case, I made one up called Kuberpack/registry v1. So it's this, so this controller that's running up in the top view knows about this thing, and it's going to reconcile something that has this class name. So let's go ahead and apply that to the cluster. We can just do that. So k apply -f bundle. So we got two of those. So we look at our bundles. At first it said unpacked and pending. So what's happening under the hood here is we, let me make sure I'm in the right namespace. So for each of these bundles, we use the underlying container runtime to actually do the unpacking for us. So because the bundle image is in a container image, we want to make use of the cluster's container image tooling and basically kubelet and the underlying container runtime interface to go and pull those images and make the content available. So we end up like building a pod that runs these. This is pretty similar to what OLM does today, with a few differences. So if you look at what these pods actually create, so if you do get config maps, so the underlying storage now is actually just like one config map per manifest in the bundle image. And then there's these metadata AP, there's these metadata config maps. So this is basically like the underlying storage mechanism that we can use to share the bundle manifest data between the bundle controller and the bundle instance controller. So if I went to create a bundle instance, it knows like, oh, well, I'm the provisioner for this particular bundle type. So I know how to load the bundles that the bundle side of this provisioner stored. And the way that this is implemented in my kind of POC is that there's just an interface. I can't remember what I named it, but it's basically load and store, and then you can write your own implementation under the hood. So anyway, so we can look at these real quick. So if I look at like the memcached metadata 0.1.0, pretty much the real interesting thing here is just that like it's immutable. Where's that? So immutable. So I can't just go in and change this and have to worry about what that means to reconcile something. So the only way to like mess with this is to delete it. And I'll show you what happens when we do that. And then the other thing is just like, here's the list of all the manifest objects. So that like, if one of those other things, if something gets out of sync, this is always the object that we look for to tell us like, here's the source of truth for all of the other bits of pieces that go with this bundle. I think that's the most interesting stuff there. So let me, so if I delete that, right? I can just keep deleting it because the reconciler is like, well, you still have a bundle and I still need that to exist. So it just keeps recreating it. Same thing if I delete that pod. In this case, it'll recreate the pod and basically recreate all of the underlying storage based on what that pod produces. So the beauty here is like, it's just always going to keep reconciling. If anything underlying what it expects to be there changes, then it puts things back. So pretty much what you would expect from what a reconciler would do in Kubernetes. So, okay, so that's all fairly straightforward, right? So one other thing we can do here is we can look at like what this actually looks like. Let's like look at this guy. So binary data object, this is just base 64 encoded of whatever YAML or whatever was in that object in the bundle. And then there's a bunch of labels that we can use to A, tell us what's in here, and B, maybe we want to select on some of these things in the future. And then we can also look at the bundle. And we get a whole bunch of status here. So this will tell us A, that the unpack was successful. It'll tell us the full digest for the thing that we unpacked. And then there's this info that tells us what the name of the CSV or the bundle name is, all the objects with their GVKs and namespaces and names, and then what package it's for and what version it is. And then, which was the last thing that all the status refers to. Okay, so that's bundles. So now the more interesting thing is probably if we actually try to create a bundle instance. So we can say, okay, so we can look at this first. Bundle instance. So what we have here, we have three things. One is the namespace that we know our bundle wants to be installed into. Another is the operator group that we know that our bundle wants. And so in this case, it's all namespaces operator group. And then the bundle instance itself. So our registry v1 provisioner class, it's going to lay down a CSV with a bunch of other things in this namespace. And then OLM is installed in this cluster. So OLM is actually going to do some of the reconciliation of this. So that's part of the reason that this can kind of integrate already with what we already have for OLM. So let's go ahead and apply this. And if we get the bundle instances, so you see a bunch of stuff going on up top. So it looks like so our desired bundle is 0.1.0 and our installed bundle is 0.1.0. So we can see if we look at our CRDs, for example, here's this new CRD memcaches. Let me create one actually. So I'm going to do, I've got another, so you saw that there's a 0.1 and a 0.2 and it has a CRD change. So I'll show you, kind of prove that we can pivot between these versions if I change that bundle instance. So for now, let me apply this. So memcached API. So if I try to do the V1, this is going to fail because the current CRD for 0.1 doesn't have this V1 API. So let me do the V1 alpha 1 API. So that works. So get memcached. And I see, so there's nothing behind this. There's just the API. So nothing actually gets populated. But the one thing I want to call out here is that there's this column called size, and that'll be important when I go and build the new CRD, because that column name is going to change because the new CRD changes the name of that field. So if we get bundle instances, we want to look at that. This one is a little bit less interesting just because I haven't had as much time to mess with this, but we just say, yeah, so the bundle name that we want to have instantiated, again, the provisioner class, and then this just says, is it installed? Yes, and here's the bundle that we installed. This could use some improvements for sure. So now let's go and change bundle instance. Oh yeah, well actually let me do something else first. So you notice a bunch of stuff kind of flew by up here. So under the hood, this is actually just using Helm's install and upgrade functionality. And every time something needs to get reconciled, it looks at a Helm release that it's created and says, is everything on the cluster the same as that Helm release? If not, then let's go ahead and do another release and either reconcile back to what it's supposed to be, or maybe we want a new release that has a new upgrade. So the first thing I can show you is that if we go and delete, I'll delete this CRD. So this sees that happened. And if I give it a second, I can ask for CRDs again. Oh, of course, I deleted my CRDs and my CR also went away. So that worked. I can recreate that. Now that's back. Okay, so that kind of shows that the bundle instance controller is going to reconcile and make sure that the thing that you've said you want is always applied, even if you are able to go and delete some of the underlying things. Now let's go and edit the bundle instance to tell it we want this new version. So we can say we want 0.2.0. So of course the reconciler does a bunch of stuff, and eventually, so let's look at our memcached. So it's terminating some of the old stuff. It's starting up some of the new stuff. Let's see if we still have our memcached. Of course, that's in the other namespace. Okay, so now it says replicas, right? So all we did to change this CRD is just edit that one line of our bundle instance to tell it we want this different version. And the other thing is we can go back, right? So let's say it's something we don't like about it. So again, that'll basically say, oh, it looks like you want something different. Give it a little bit and let's see, and there's size again. I think that's all I had to show. If there's any questions or comments, the one thing that I'll call out here is that OLM today does a bunch of smart stuff around like CRD upgrades and making sure that things are safe and the data is not going to get lost. This demo, like if I made some horribly breaking change in the CRD, it's not going to solve that problem for you. It's going to just apply that blindly. The other thing that I wanted to show, which we've been talking about a lot, is if I delete the bundle instance, then everything actually gets deleted, including the CRD, which is something that I think there's probably some consensus that that's probably what we want to do, right? So we deployed everything that was in that bundle when we created the bundle instance. And when we delete the bundle instance, we're going to delete everything that was in that bundle instance. So if I get my CRDs again, you'll see there's no memcached anymore, which also means there's no operands. But we've also cleaned up everything, everything associated with that bundle, which I think people have complaints about. We can create a subscription and a bunch of stuff gets installed. And then if you delete the subscription, oh, by the way, you also have to go delete these other things. And even when you do that, like you still have to delete the CRD and some of the cluster roles. So this is a different way of doing that, which is a little more declarative. And a bundle instance means like the bundle is applied, and the lack of the bundle instance means that stuff is not here. Okay. Questions or comments? I know that was 15 or 20 minutes of me just straight talking, but this is really interesting to me. So hopefully you guys found it interesting too.
So just a quick question from a high level, right? So the bundle and the bundle instance, is that really going to be a first-class API you're expecting customers to use, or is it really kind of an underpinning of the operator API? Are you expecting customers to use both?
So I think so first of all, like, because it's an API in Kubernetes, like people will use it, even if we don't intend for it to be used or not, right? So the first way I'll answer that question is, regardless of our answer for what we think it should be, like we need to design it such that it can be used as a first-class API. I think like we're intending this to be one of the primitive types that like there's gonna be some other components that know how to stamp out bundles and bundle instances. Does that answer your question?
Yeah, it does. So I just wanted to make sure, because CSVs originally were kind of like this, right? So CSVs stamped out a single instance, provisioned a single instance of an operator. And now it doesn't really work that way anymore. You have to use a subscription because of the way the ownership and a bunch of things kind of just changed over time. And so CSVs, at least in my testing, don't work anymore if you use them by themselves. So I just wanted to make sure. So yeah, so I think bundles and bundle instances are cool because I think they really help, especially for like GitOps kind of scenarios, where you want to be able to replicate cluster configurations across large enterprises and things like that.
Exactly. Yeah. And especially if you don't care about the resolver, or you know that you can pivot between different versions, maybe you don't care about the rest of the higher level things. Maybe you just want to say, here's exactly what I want my cluster to look like, make it so. So yeah, I think part of what we're hoping to do is make it so that all of the APIs that we're coming up with can basically be usable and standalone and have a lot of predictability on their own. But we're going to be building on top of these too.
Joe, I actually have a quick question for you. So you did mention briefly at the beginning with the provisioner, and from what you said, the fact that it's basically a job. I try to find a way to put it correctly. It's basically the ability to enable the fact that this bundle particularly can be many different type of bundle that is based on the content inside it, and this provisioner is supposed to be the one that knowing what type bundle this is, what type of bundle it is, and provision it properly and resolve it properly. And I'm just curious how you're supposed to configure it provisioner, so to speak. Is it a mechanism to providing something that can actually spin up, so to speak, this provisioner?
So the way that this works, let me see if I can find it real quick, actually. So like all I'm saying here is I've got a filter on my watches for bundles that say like, watch all the bundles, but don't let me reconcile them unless they have this string as their provisioner class name, right? So that's all that's doing. So effectively, the way to build another provisioner is to copy all of this code and change that one string out to a different string and then do your own thing. So you can just run new instances of controllers that know how to watch these APIs and just use a different provisioner class to dictate which instances of those things you're going to be reconciling. So this is very similar to like the whole ingress an ingress class idea.
I see. Thank you. So this is something that you basically have to coding around this and pretty much contribute to OM. Is that what it's going to be?
So right now, this is just like a POC I put together so that I could show people what was in my head and, basically provide some insight into what I think the RuckPack API looks like in my head. I know Tim has been looking at this and getting some inspiration from it, but if we want to just merge this into RuckPack, I'm happy to do that. That wasn't my intention, right? Like I'm just trying to, brainstorm and come up with ideas. And this is what made sense to me. And this was something that was honestly like fairly straightforward to build. The thing that was kind of the linchpin is that like a lot of the stuff we built in Operator SDK for the Helm operator, I could reuse here. So it's basically like the code here is basically reading the bundle, building that into this ephemeral Helm chart, and then just handing that over into the Helm operator SDK's libraries to do the like install, upgrade, does it need to be upgraded kind of logic. And then you get a lot of stuff for free, right? Because in Helm, like in the Helm operator, it will create a release, store that in Kubernetes for you, and then make sure that like that release is the thing that's present on the cluster. So you never have this case where like you're trying to pivot, but you've lost what your previous state was in case that pivot fails, right? Like the idea is we're going to try to pivot, and if it fails for some reason, we can put you back to the state that you expected to be before we tried anything.
Interesting. I know I may ask a question a little bit ahead of time, so to speak, but do we envision or potentially allow this provisioner to be something that can be, be provided separately, so to speak, in a way that, it can be deployed on a cluster without OM have to care about the, care about it in the sense that it will essentially allow, I don't know, cluster admin or whoever to just deploying some sort of a controller like the,
right.
And that way, and this basically OM just need to know where that is and use it, doesn't care about the implementation detail behind that, so to speak, and it become a separate component from OM.
Yeah,
is that something that possible?
So I think of this as like just an extensibility piece of this, right? So these APIs are generic and they're not necessarily like OLM's APIs. They're APIs that OLM will use, and OLM will define its own provisioners for the bundle types that it knows how to handle. But theoretically, you could imagine that, some other group or vendor or company wants to design their own provisioner because they have their own bundle type, and potentially even make use of the higher level object types. As long as we like build the higher level like operator API and some of the DEPI stuff generically such that it treats these bundles opaquely, then like you can make use of all of that with your own bundle types. And at the end of the day, then like it'll create these bundles and bundle instances that have your provisioner class name in them. And then you could deploy your own provisioner that knows how to actually deploy that stuff on the cluster. So yeah, I think like I would imagine that OLM is just a collection of controllers that implement these APIs with like specific names for the provisioner classes. So it's basically a flavor of implementation for these APIs.
Oh, thank you.
Yeah, so OLM is no longer OLM anymore. Now it's BLM. Bundle Lifecycle Manager, right? So we're being able to provision anything that you can dream up, and you plug it in just like you plug in storage classes and provisioners for those. And
right. Yeah. And hopefully we can build it such that like you can make use of some of the pieces that come in the OLM distribution. You can basically build your own distribution, right? And some of the pieces you might pick from OLM's distribution, and some of the pieces you might build yourself.
yeah, so I can envisioning 2 layers. You have basically this scaffolding, this framework for generalizing provisioning stuff, and then OLM becomes an implementer of that.
Right.
All right, then. Is anyone else have anything else they want to ask?
Have you guys looked at the what is it called? The cloud native archive stuff?
CNAB.
CNAB, yeah. So CNAB has a little, I haven't looked at it for a long time, but they're a little more opinionated because I think they required you to have actual Linux provisioning scripts and things like that inside your Docker images, where this is a little bit more declarative approach. Have you looked at that at all to see if there's any parallels there or any reuse there?
I personally have not. I think that some of this, like when Evan and I don't know, Nick, if you're on the call, if you've seen any of this, I feel like the OLM team has looked at that. It might have been a while. I think some of the inspiration may have been derived from there. I personally know about it, but haven't actually delved in too far.
Yeah, okay, I was just curious. I haven't looked at it for, it's probably been 3 years.
All right, is there anything else? Anyone want to speak up on this topic? All right, then I will take the silence as a no. So we don't have anything else for the meeting today, but I just would like to ask real quick, anyone have anything they want to bring up, given that we still have a little bit of time left?
Yeah, I guess I've,
Oh, sorry,
go ahead. You go right ahead. I'll tag on the end.
All right, thanks. I had a question regarding installation of dependencies. Seems like right now the way to do it is by specifying something in the dependencies YAML that's part of the bundle. And there's no way to control where the dependencies get installed. It seems like they'll always be installed in the same namespace as the operator who's requesting certain dependencies.
Correct.
I'm wondering if there's any sort of direction or thought around that, or if anybody had sort of similar issues with that, as in the need to control where the operators go, the dependent operators.
Oh yeah, so I can answer that for you, Sid. So first of all, yes, that's correct. When you declare dependency for your operator, you normally specify them in the dependencies.yaml, which is going to be packaged inside a bundle. That's correct. And the way OM resolve dependency is the namespace resolution, meaning that it will resolve dependency for every single operator that in the same namespace together. And I emphasize the word together in the same namespace. And this has been the same behavior for OM pretty much from the start, meaning that every single dependency will get resolved together, and obviously will resolve into a set of dependent operator along with the main operators, and all of them will get installed on that particular namespace because they having connection together in the sense that they get resolved together in that namespace. And that has been the behavior ever seen. And currently, as Yuri mentioned it, we do not have a way to resolve dependency on a different namespace along with your existing namespace already. That is not the behavior that we are doing at the moment, and we currently do not have any plan to allow that to happen. So anytime you want to installing a different operator, regardless if it's the main operator or dependent operator on a different namespace, you got to do that on the other namespace, not on the namespace that you intend to installing your main operator. As far as I know, we currently do not having any use case about installing a main namespace in the main operator, I'm sorry, in this namespace and the dependent operator in a non-namespace. We currently do not see any use case for that yet, but I would love to hear what you think about that.
Yeah, the problem or the potential problem is that if the dependent operators sort of like have sort of privileged roles, you're kind of leaking those roles, right? So if you kind of by default install all the operators in the same namespace, there'll be some roles installed by some privileged operators that have sort of privileged access, right? So and anybody in that namespace can kind of assume those roles, right? Or bind to them in theory.
Yeah, I can see that, but the issue is the fact that the resolution in the namespace, because they actually resolve together. And again, I want to emphasize the word together, meaning that in this specific case, you mentioned the dependent operator basically just matter to your main namespace only, but we cannot guarantee that's only the behavior, and that's not always the case in the sense that your dependent operator may matter to a non-operator beside your main operator in that specific namespace, right? So that's why they need to get resolved together to make sure that we fulfill owner requirement in terms of dependency for everything in that namespace. And if you want to install the operator in another namespace, then we need to take in account that namespace as well in the resolution. And then we need to know what's happening on the other namespace to even get everything together, meaning that you eventually resolve two namespaces together. And if you continue with that process, you pretty much resolve the entire cluster together. And that's not something OM currently doing.
I would say though, like, I think we all recognize that this is one of the problem areas with OLM, and like so the demo I was showing earlier, all of that, like all of those bundle and bundle instance APIs, those are all cluster scope CRDs. And the idea with the newer APIs is that like there is no more namespace based resolution. It's all kind of at the cluster level. And then like, yes, you can then install different operators in different namespaces, but the resolution for like what needs to be installed happens once per cluster rather than like once per namespace. So unfortunately, I think the architecture of OLM now is such that like it's basically impossible to solve that problem with the current set of APIs, but that's one of the main use cases for why we're coming up with this new set of APIs.
Yeah, so just FYI, from a consumer perspective, so with IBM, and so we're mostly a consumer of OLM. We've kind of discovered this same problem, and so we've had different products develop different orchestrators, like client-based orchestrators, or you call them meta operators, umbrella operators, that basically build up relationships separately from OLM because of the complicated use cases you can have. I mean, the use cases could be crazy different, right? Depending on what you're looking for, if you're security focused or if you're tenant focused or those kinds of things. So yeah, so OLM does really good at a set of things that it does good, but these other use cases are going to be solved, I think, in this other, I'm calling it the generation 2 APIs, which will have a whole different way of describing those kinds of relationships and provisioning them.
Yeah, so I see what you're saying, Chris. And I think Joe already mentioned that the current architecture doesn't allow the cluster scope resolution to happen. And there's some historic reason behind that. And also for the fact that the way operator is being built at the moment is also can be namespace and can be cluster scope as well, depending on what kind of operator that is. And until we still having a namespace scope operator, so to speak, then the namespace resolution still needed for that specific reason. And until we can actually keep synchronizing everything across the way the operator being built and also the way OM resolve dependency together, and at that point on, we potentially be able to do something a little bit more bigger scale in the sense that OM were able to resolve dependency on an entire scope of namespace, and that's something can be done in the future when we actually resolve only the underneath layer of the fact that everything still stick to the namespace resolution at the moment on the operator side and also on the OM side as well.
So the short answer from a consumer of it, not a developer of OLM, is if you have customers who have some narrow or some requirements like this, don't express them as OLM dependencies. Express them some other way and then provision subscriptions some other way, right? So don't let OLM, don't provision a top level operator and have the dependency provision the subscriptions for the child operators, depending on who your clientele is. Instead, create a script or a Helm chart or something like that to create the subscriptions for you and to make sure you get them installed in the right order. OLM isn't going to protect you from making mistakes if you update things that have APIs that break and things like that, because the dependencies won't be there. But at least it gets you that more narrow security footprint that you're looking for.
Yeah, that sounds the way that we're going to go. I just wanted to check if there was something that we didn't know about.
Yeah, so Chris already said that dependency resolution in OM is not required by any means, in the sense that it will give you a feature for you to take care of any kind of namespace dependency for sure. But if your intention and your use case specifically is not on a namespace scope, then you can certainly using the model of doing multiple different subscription on multiple different namespace to installing your operator at their independent operator without have to rely on the dependency resolution of OM. And to what Joe also just demo right there, that will be the future for that. You can literally just create a bundle, instant, and that will take care of that for you. Meaning you just need to create that bundle instant in that specific namespace, and OM will install that for you. And you basically just need to do that for your main operator in this specific namespace and your other operator in the other namespace, and that should be taken care of. And then you don't need to rely on the dependency resolution for the namespace scope. Until hopefully in the future we're having a more cluster scope resolution, then at that point you can certainly use it.
Yeah, I was just gonna say CRDs are cluster scoped anyway, right? So the sort of namespacing of operators, at least in my head, is mainly for ensuring the RBACs don't leak across different namespaces.
Absolutely. All right then. Is there anything else from anyone else?
Yeah, I have something. So it's kind of related to this. So we brought up the dependencies YAML, right? So the dependencies YAML, I just want to make sure I understand. So last summer, you guys introduced the properties YAML to the bundle. And really, internally, what happens is OPM registry add converts the dependencies YAML to internal properties inside the catalog. And that's really what surfaced through the gRPC APIs and everybody consumes. So really the only consumer of the dependencies YAML is OPM registry add or OPM image add. And so what I'm asking is dependencies YAML deprecated in favor of properties YAML now?
The answer is no. We currently still supporting them both, the property.yaml and dependency.yaml. And the dependency.yaml.
Well, I get that. So deprecated versus removed. So deprecated meaning if you're going to write something new using the modern tooling, you shouldn't use dependencies YAML. You should really use properties YAML. Is that an accurate statement?
I wouldn't say that it should. I wouldn't say that the phrase for that, because the internal conversion for gRPC is mostly something that we do for the sake of simplicity in that sense. It is easier for the OM side to consume it in that way, because for the record, on the OM side, we actually specifically knowing in advance what type of property that we consider as the constraint and dependency, and we will do that at runtime. But from the registry perspective, they are actually different in that way. That some of them are dependency and some of them are just property that we will not get into, resolve them into some sort of dependent operator. So you, technically speaking, as you already said it, you can combine them into one single thing. And
But
basically,
let me clarify. So the dependencies YAML is actually a subset of the properties YAML, right? So the properties YAML could do everything that the dependencies YAML could do. Is that right?
That's right.
yes, that's correct.
All right. So that said, and the fact that almost all of the EPs, enhancement proposals that are coming out, never mention the dependencies YAML anymore. They're always expressing things in the scope of bundle properties. It sure seems like the dependencies YAML's kind of on its way out. So I'm wondering
Yes.
if we should deprecate dependencies YAML.
Yes, so there is a thought about eventually deprecate the dependency and consolidating everything on the property.yaml for the sake of simplicity, and it's easy, basically kind of streamline the process of how the metadata been specified on the bundle. So that is a thought behind that, but we currently have not having a specific plan for that yet because it's still in supported API. So we need to find a way to properly and timingly, so to speak, deprecate that accordingly. And hopefully we're going to having an enhancement proposal perhaps to make sure that that thing will get deprecated the way that people are aware of that, and make sure they migrating everything they needed from dependency.yaml into the property.yaml. And
yeah, I guess maybe to start with, if we could just make sure we elevate, because the properties YAML kind of snuck up on me last fall. I didn't realize how much it was used. Is basically it was introduced as an introducing arbitrary properties, and didn't appreciate the fact that it also consumed all of the dependency YAML properties as well. So it took me a while to get that. So I'm thinking a lot of other people are going to be confused by that too.
Yeah.
So I'm wondering if we should elevate that in the documentation, saying, hey, by the way, you have two ways of doing it now that the dependencies YAML is likely to go away. If you're going to do something brand new using the newer versions of OPM, I think it's 1.17.4 or later, use properties.
Yeah, so there's still a little bit of distinction between the two of them. So I don't want it to be something that people may misunderstand about this. The property.yaml, as you mentioned, is supposed to be add some sort of like custom random property that matter to you as the developer of the operator to basically package the bundle. But whatever you put in the property.yaml is basically for you. Sometimes OM will not understand what kind of property that is. So that I want to make sure that being clear. Doesn't mean anything including there, meaning OM is supposed to understand that. That's not the same thing. And most of the time, the property that OM is generated for the resolution runtime is actually something OM generated itself at runtime. So you don't actually see it. So property.yaml is the way for you to explicitly specify something that OM would not normally generate by itself. So that way, basically custom property, so to speak. And dependency is have been always the first class play for you to specify specifically dependency, like om.tvk, om.package, and now the new type om.constraint. And if you convert those dependency into property, you need to be careful. om.constraint is a new type that fully supporting both places, but the other two, the GVK and the package, you need to changing the type a little bit. I mean, this has supposed to be dot.
Oh yeah, they're not a one-to-one.
Yeah, so that thing, it had not been entirely communicated to the upstream yet, and it's because we haven't had a plan to deprecate it dependency.yaml yet. So that's why we haven't put the text and the context and everything up to the community yet, and for the upstream purpose for that reason. So until we had a plan to do that and make sure everyone aware of this problem, I mean, not problem, but this specific detail, then I would recommend to continue using dependency for now until we have a way to do that. Because I don't want it to be confused and then people using it wrong and it doesn't work and they get frustrated. That's for sure not the intention.
So my perspective is that it's probably already confusing. So the faster we can make a decision about how we want to do that and consolidate, probably the better. In my mind, like dependencies and properties.yaml, the only purpose for those in the bundle is to let OPM consume them to build the index. And then by the time it's in the index, it's already been converted to properties. And from then on, as far as OLM is concerned, it's properties. So in my mind, like that's probably a pretty good indicator that we should just make it properties all the way through the chain to decrease the possibility of being confused around there.
Yes, exactly. It's depending which one of the OLM developers, I'm not going to name names, I get a different opinion about which property to use. One person says, yeah, we should have deprecated that thing, only use properties. The other person says, no, use dependencies. And so, and all the EPs, especially like the compound constraints EP is being reviewed right now, That one doesn't talk about dependencies YAML at all, right? So then as you're trying to be a producer of a bundle, you don't know what the heck you're doing. You look confused. How the heck do I use these? How do I consume these things? Because I'm not building, file-based catalogs yet. And they're really from the perspective of a bundle property in a file-based catalog. And then you put the two together. So I think the examples in there need to be dependencies YAML examples, if that's what we're still endorsing.
Yeah, so for the compare constraint EP, clearly that was an oversight there, because if you look at my EP, the generic constraint, I do specifically mention dependency YAML, because that's still the main play for it, even though it can be supported on the property.yaml. Because again, I just do not wish to mixing them together until we had a plan to do that properly. And clearly, as you said, that maybe we should do that a bit sooner. The fact that it's already become a get an impression of the fact that those two become merging together and one of them going away, even though that's not in any plan anytime soon, and not anytime soon, but not in the plan at the moment yet. But given that perspective, I think we should create an issue on GitHub and then gradually finding the way to make sure this kind of detail come up and make sure that we decided to deprecate one of them and then go from there in terms of that, even on the API perspective, that we no longer support accepting dependency.yaml, for example, that you need to migrate them away or anything like that, then we will make sure that come up. So thank you for that.
Cool. So just make sure I understand. So the only consumer dependencies YAML today is OPM, right?
Correct.
Okay, yeah, I just want to make sure,
because I just want to.
It's really the properties. It's really the properties in the catalog that are consumed by OLM.
Yeah, because the thing is, the bundle itself is eventually need to be translated into something that you already know, right? It's going to be either a SQLite database or the file by catalog sort index data point. And at that time, when it's been translated into a the consolidated index information of a bunch of different operators together, then at that point, you don't need the dependency or property.yaml for that matter, because that's only on the bundle side, not on the index side.
Yep, got it. All right, I'll create an issue so we can just kind of decide to tackle it or not tackle it. Just put it in the backlog. Yep, I'll do that.
Great. Thank you.
I do have one other related question.
Sure.
If anybody else has one. I think Joe's raising his hand.
I think that's from previous, and that.
Okay.
Go ahead, Chris. That was from a long time ago.
Okay. I just noticed it. So the other one I had is, so we talked a little bit about, so Joe, I created an issue a while ago talking about who the source of truth is for the file-based catalog for the bundle information. And I think I definitely understand, channels and the upgrade graph, and those things are obviously the things that are the source of truth within the catalog. And I think we also agreed that the contents of the OLM bundle are really designed, they're supposed to be immutable. They should match whatever is in the actual bundle image. And so if you update things, then you're going to get a whole bunch of unexpected side effects depending on, who's reading what at what time, right? Especially like with the package server and things like that. The question I have is dependencies. So dependencies right now are converted, as we just talked about, from the dependencies YAML inside the bundle. They're elevated into properties inside the file-based config or file-based catalog inside the OLM bundle object. Have you guys considered elevating that also into a separate dependency graph rather than having it be part of the bundle? So I could maybe say, oh, I know I created this version of this operator and I made the dependency too narrow. I don't want to change the operator, but I can actually change it to a different, package name dependency or a different semver range because I screwed up and made it too narrow, or I want to be able to accept something else in this particular curated catalog.
I can speak to that, even though I probably pun that to Joe, actually, given he actually probably can speak more about the file by catalog source. So yes, so set aside the sort of two part of your question, something I would rather let Joe answer that part. But for the other part of it, the fact that the dependency information is on the bundle, right? That is at the packaging tab at the bundle itself. And when you go through the OPM process, translate it into either file-based catalog source or the SQLite one, everything be converted into basically update hash in the database or into the property on the file-based catalog source. And at that time, that specific information is already on the index. The bundle is just a vehicle for us to get the manifest, the cube manifest that you see model anymore. You see what I'm saying?
I know,
So
that's an implementation detail. That's not really part of the spec, right? The spec is a little bit loose on what parts of the FBC are authoritative versus not authoritative.
So the only thing that's not authoritative in the FBC is the manifests that get applied to the cluster.
Correct.
So everything else, like everything about the metadata and everything like related to what gets shown in the package server, all of that stuff comes from the catalog. All the resolution decisions are based on what's in the catalog.
Yeah.
I haven't experienced that. I've done a bunch of testing and I'm not seeing that. If I override my properties for my dependencies, I don't see those being honored all the time. It's weird. I don't really, it's not consistent. So hence, that's why I had to ask that question. Who's the source of truth?
I would say that's the expectation. And if you can have a reproducer that shows that that's not happening, file a bug.
Yeah, so
sorry, one other thing I wanted to mention, Vu, is that in the gRPC API, every entry in the list bundles is associated with a channel as well, right? So like if I have a bundle entry that shows up in 2 or 3 channels, I'm going to get 2 or 3 bundle entries in the list bundles API. And as far as I know, like anything in there can be different, right? Like I can have different skips replace a skip range, which is already supported now with the channel schema. But also theoretically, as you're saying, Chris, like there's no reason you couldn't have anything else be different. So I think I'm pretty sure I've heard someone else ask for this exact same thing within the last week or two. So clearly it's something we probably want to think about, but yeah, maybe we want to have more fields under the channel dot entries, like the channel dot entry type, so that you can change different things about what that particular entry of that bundle looks like. It gets a little weird then because like, you know, do we want to allow bundles to specify a default, or is that like, do we allow those to be overridden? Like, can you declare them twice and one takes precedence over the other? So those, I think, would be questions we'd have to answer about like how we'd go about doing that. But from the gRPC API standpoint, it should be possible to have like everything other than the bundle key can change about the bundle.
Yeah,
because I'm trying to come up with a pattern for all of our products to use in our own pipelines. Because I had mentioned this before. We've got basically a master pipeline that takes in all 150 products and we populate one catalog. And so, you know, our source of truth used to be the bundle. So now it's going to be the bundle for some of it, and it's going to be something else for the channel definitions. And so I'm debating whether we need to have something else to override some of those bundle definitions if we want to, like, for example, change the dependencies.
Yeah, so John Reed said it. I'm a little bit surprised to hear what you said, that you're changing the JSON blob, you know, JSON or YAML blob for the index for the catalog source, for the file-based catalog source, and it did not resolve into what you expected to be. That's potentially a problem there. So I
think part of it might be the package server is getting in the way, because the package server is still doing old stuff.
Yeah, so I would love to hear if you can give us a reproducer for that. So we can look at it. And just one thing real quick. So I think can potentially see the problem here, the fact that when you're changing the update hash, normally you're changing on the, you know, not the bundle, I'm sorry, like on the bundle blob, you mean the JSON blob in the file-based catalog source, you're changing like, you know, skip range, replace and stuff like that. But it does not mean that will translate into the bundle.object blob, which is going to be surfaced on the package server on the console. That is not equivalent. So you need to update that blob as well, if that's the case, to make sure it's consistent with what you see on the console. So that is something that you need to be aware of. But again, I except for the bundle blob thing, everything else, as Jory mentioned, in terms of like update hash, any cap information channel related and stuff that should be the sort of shoe is on the index side, the file background sort. And the only thing get installed in a cluster is the bundle, which is we only care about the manifest, not the rest. So that should be a main thing there. But you know, as Joe said, it we can having a further conversation about where things are supposed to be and if there's an easier way, a more logical way to get on this update hash information, upgrade hash information to be somewhere else, then we can talk about that for sure.
Got it. Okay.
All right, then. So I think we're at time now, 1 minute away. So I think that should be the end of this specific meeting. We're obviously having another item that we light up for the next meeting. But if anyone else have anything else between now and then, feel free to add to the agenda list, please. That would be nice. So thank you in advance, and thank you for joining today. And I hope you're having a great day. And we'll see you in the next meeting. Bye for now.
Thanks, everyone. Bye-bye.